students, you are welcome to Dr. OJ's tutorial class. In this video, we shall discuss a trigonometric function that has the form a cos theta plus b sin theta. Stay blessed as you watch. Now, in this form, a cos theta plus b sin theta. In this form, a and b are constants. These are constants. They are constants. They are real numbers. Okay, y theta is an angle. Y theta is an angle to be found, So how do we go about any form of a trigonometric function that has this? Okay, now let's a cos theta plus b sin theta be equal to r into sine theta plus alpha. We are introducing alpha where alpha is to be evaluated. We want to know the value of alpha. Okay, now if we assume this from the right hand side, you might be asking, you might be wondering, how come I use r? R here is a variable, it's a variable constant. Theta is the known angle, while alpha here is the value to be evaluated. We introduced alpha, so we want to know what it is going to stand for in the course of this evaluation. Now, we use r sin theta plus alpha simply because if we expand this, we are going to have a addition sign that we have here. Okay? Now, let's go about this. So, from the right hand side, that is r sine of theta plus alpha. We can have this. If we expand, we have r into, sine, theta plus alpha is sine, theta cos alpha plus cos theta sine alpha. I hope you can still remember that. Okay, we've done this previously. So when you expand everything here, you have what? R sine theta cos alpha plus r cos theta sine alpha. So that is what the right hand side expansion will give us. Now, which implies that this then implies what? Implies that a cos theta plus b sin theta is now equal to what? R sin theta cos alpha plus r cos theta sin alpha. Okay, now let's try to look at the left and the right hand side and see if they can be compared. Okay, so we compare the coefficients in left hand side and right hand side. Okay, the left hand side say what? A cos theta plus b sin theta is equal to r sin theta cos alpha plus r cos theta sin alpha. Okay, so now if you look at the left and the right hand side, you see that there's some values that are common that we can bring together. Let's take, for example, cos theta. A cos theta. Looking at the other side of the right hand side, you see we have cos theta here too. So we can pick this one and this. We can compare a cos theta with r cos theta sin alpha. So that implies a cos theta is equal to r cos theta sin alpha. Because cos theta is found here. Remember, this is cos alpha, so you cannot compare this with this. It is cos theta that we are comparing. Okay, so that implies that if you cancel out cos theta, you'll be left with what? A will be r sin theta. So let's call this one equation Roman figure 1. Now, doing the same thing for b sine theta. Where do we see sine theta? Sine theta is over here. So you can say what? B sine theta equals to what? Equals to r sine theta cos alpha. So cancelling out sine theta, you have b is equals to r cos alpha. Let's call this one what? Equation 2. Okay, now squaring both equations and adding them together. Squaring, let's go here. Let's come here. Squaring and adding equations 1 and 2. Let's go and add them. Okay, equation 1 will be what? A squared is equal to r sine alpha all squared, which will be what? R square sine square alpha. R square sine square alpha. Then for the next one, b square, we are squaring and adding, is equal to r cos alpha all squared. Will give us what? R square cos square alpha. Okay, adding them together, we have what? A square plus b square is equal to what? R square sine square alpha, sine square alpha, plus r square cos square alpha. So which invariably means what? A square plus b squared is equal to r square is common. R square into what? Sine square alpha plus cos square alpha. And don't forget, in our trigonometric equation, sine square theta plus cos square theta is equal to 1. So in this case now, sine square alpha plus cos square alpha is the same thing as 1. So that implies that we have what? A square plus b square is equal to what? R square. Why? Since sine square alpha plus cos square alpha is equal to 1. So with that now, we can say that. How do we now get our r? We can find us what? Finding the square root of both sides, finding the square root of both sides. Okay, so we have what? Square plus or minus square root of a square plus b square is equals to r. So our r is now what? A square plus b square. So now that solves the value of our r. Now going by what we have in equation 1 and equation 2. Recall, A is equal to r sine alpha. So that is equation 1, which implies that if A is equal to r sine alpha, that implies sine alpha will be, if you divide both sides by r, to get sine alpha, divide both sides by r, A all over r, which is A all over. Your r is what? The square root of a squared plus b squared. Okay, the same thing goes for b. B is equal to r cos alpha. So to find cos alpha here, b all over r will be equals to cos alpha. That is, if you make cos alpha the subject formula, which implies that what? Cos alpha will be b all over square root of a squared plus b squared. And looking at equation 1 and 2 again, equation 1 and 2 again, this a equals to r sine alpha and b is equals to r cos alpha. You know that. If you say since r sine alpha equals to a and r cos alpha equals to b. So if you divide this equation 1 and 2, don't forget. Okay, if you divide equation 1 by 2, if we divide equation 1 by 2, what do we have? Okay, we have r sine alpha all over r cos alpha is equal to what? A all over B. So and obviously here R will cancel R. And sine alpha over cos alpha is equal to what? Is equal to tan alpha, which is what? A all over B. Okay? Now tan alpha is equal to A all over B. How do we get alpha, which I told you about the other time? So alpha will now be equal to what? Arctan, that is tan inverse of A all over B. So that is the value of our alpha. So now going back to the formula or to the function given to us, therefore A cos theta plus B sine theta, which we call what? We said from our evaluation, we said it should be R sine of what? Theta plus alpha. So we can now say that is equal to what? And our R, what did we get for our R? Our R is what? Plus or minus, equals to plus or minus A squared plus B squared. Sine what? Sine theta plus alpha. So that is the value of the function A cos theta plus B sine theta. We can have an alternative version of this when we use cos. So let's look at the alternative version of this when cos is used. So suppose we want to put the value of our alpha here, we just put whatever value our tan inverse of A over D gives us will now be put there. Okay? Now let's look at the other version of we use R sine theta plus alpha here. Let's assume that we use a version of cos. Okay? Let's use version of cos. Let's put this thing in half like this so that it will be easier. Okay? Now, alternatively, let A cos theta plus B sine theta be equals to what? R cos theta minus, we can use alpha, we can use beta, we can use anything. So, let's use our alpha back. Okay? Let's use our alpha back so that we understand it easily. Yes. Now, suppose that, in the previous example or illustration, we use R sine theta plus alpha. Why don't I use plus here? The secret is that I want to retain my positive sign here. And if I expand cos theta minus alpha, it gives me positive sign. So if I put plus there, it will change this one to negative. The evaluation will be negative, and which is not going to be conform with this. So I want a conform version of cosine. Cosine will change negative to positive and positive to negative. Since the sign here is positive, I have to take minus, so that by the time I expand this, it will coincide with the sign I have there. That's the trick. So now, expanding R cos theta minus alpha, we have R into cos theta cos alpha plus sine theta sine alpha. So by the time I expand that, I have R cos theta cos alpha plus R sine theta sine alpha. So that's the expansion of this, which implies that this now implies A cos theta plus B sine theta is now what? R cos theta cos alpha, plus R sine theta sine alpha. Okay, now, like we did in the previous one, let's compare the values of cos theta and the sine theta. So, if you look at this now, this has cos theta, this has cos theta. So, I'll pick this one and this, and this one has sine theta, this one. So, I'll pick that like that. So, then I have what? A cos theta is equal to what? R cos theta cos alpha. So cos theta cancelling cos theta, you have A equals to R cos alpha. Let's call that one. And for the second one, where we have sine theta is there. You compare this and this together. So you have what? B sine theta is equal to what? R sine theta sine alpha. Sine theta cancels sine theta. You have B is equal to what? R sine alpha. So let's call this one what? Equation 2. Okay, so if I square them, or before squaring them, I can easily, just like I did for the other one, if I divide, let's look at how I can get tan theta here. You know, if I divide r cos theta by r sin theta, I will get cot. In other words, now let's say divide equations 2 by 1. I want a version of tan. Okay, so I'll say that b equals to, equation 2 is b equals to r sine alpha. So equation 1 is, so say all over a, all over, this. I could have done it a equation 1 divided by 2, but it will eventually give me cot. But I want a version of tan. So, and tan is sine over cos. So that's why it's now b over a. So r we cancel r out. So I will have what? B all over a is equals to tan alpha, from here. Okay? So alpha will not be what? Tan inverse of b all over a is equals to alpha. So I've gotten my alpha there. Now, how do I get my r? How do I get my r? Let's look at how we could get our r. We've gotten the alpha. Now we need to get what? We need to get r. Okay? Now, let's squaring and adding equations 1 and 2. Squaring and adding equation 1 and 2. When you square equation 1, you have a square equals to r square cos square alpha. When you square equation 2, you have b square equals to r square sine square alpha. So when you add them together, you have what? A square plus b square is equals to what? R square cos square alpha plus r square sine square alpha. So what is common here? You have r square is common into cos square alpha plus sine square alpha. And that is going to be what? R square times 1. Because cos square alpha plus sine square alpha is 1. Which implies that what? A square plus b square, is equal to what? Is equal to r square. Find the square root of both sides. You have square root of a square plus b square is equals to r. So we have gotten that as our r, just like we did in the previous illustration. Okay. Now, what next? What next? Okay. Now, recall that a cos theta plus b sine theta was given to be what? R cos theta minus alpha. So that will invariably be, what is our r now? As the square root of a square plus b square cos theta minus alpha. Okay, so that is the form of a cos theta plus b sine theta. Now let's look at an example to illustrate this form that we have derived a variable or a variable formula for. Let's look at an example. Let's look at the very beautiful example here. Now we evaluate example. Evaluate 3 cos theta minus 4 sine theta, that is equal to 2.5, equals to 2.5. I think that is okay. That's the question. Now, if you look at this question, it works closely with this function. If you look at the function here, a cos theta plus b sine theta. So a here is what? Is 3, and b is minus 4. Now we have the right hand side of the equation. We don't know what it stands for. That means whatever we obtain here must be equals to this. So what do we do here? What we are thinking going to do is that let's find the equivalence of the left hand side. 3 cos theta minus 4 sine theta. Let it be equals to a function of r, a function of cos theta. So theta plus alpha. Why do I choose theta plus alpha? Fine. Because if I expand cos theta plus alpha, it will give me a negative sign. If I take minus here, it will give me a positive sign, which is different from what we have. So my target is also to ensure that my expansion can align with the sign I have here. So by the time I expand this now, you have what? R cos theta plus alpha will now be equals to what? R into cos theta cos alpha, minus sine theta sine alpha, which will equals to what? R cos theta cos alpha minus R sine theta sine alpha. Now comparing this with what you have here. So you have what? Comparing 3 cos theta minus 4 sine theta is what? R, cos theta cos alpha minus R sine theta sine alpha. So looking for cos theta here. Okay, so we have what? 3 cos theta, equals to R cos theta cos alpha. Now, cos theta cancelling cos theta, you have what? 3 equals to R cos alpha. So let me call that one equation 1. Looking for sine theta here, you have minus 4 sine theta, because it's minus, is equal to what? Is equal to minus R sine theta sine alpha. Minus cancelling minus, sine theta cancelling sine theta. You have 4 equals to R sine alpha. So that forms what? Equation 2. So from here we can easily get our tan theta by dividing equation 2 by 1. Dividing equation 2 by 1 gives what? Gives 4 all over 3 is equals to R sine alpha over R cos theta. So that would be what? R is cancelling R. That what? 4 all over 3 is equals to tan alpha. So in this case now, alpha will be what? Alpha will be tan inverse over 4 all over 3. And alpha will be what? Tan inverse of 1.333 and so on. Okay, we have gotten our alpha. How do we get our R? R is the next thing now we must look for. How do we get our R? Fine. Ordinarily, if you still remember very well, it's very easy to get R using our previous illustration. But squaring and adding equations 1 and 2 gives, 3 square is what? Is equals to R square cos square alpha, which was 9 is equals to R square cos square alpha. The second one, 4 square is equals to R square sine square alpha, which is what? 16 equals to R square sine square alpha. So by the time you add both together, 9 plus 16 is equals to R square cos square alpha plus R square sine square alpha. That is 25 is equals to R square cos square alpha plus sine square alpha. Is what? R square, because this is equals to 1. So therefore, in this case now, therefore, R is equals to plus or minus square root 25. So R is equals to plus or minus 5. So we have gotten our R to be equals to plus or minus 5. Now, what's next? That implies this now implies that the value given to us what we are given A3. Let me check. Well, the value given to us is the equation 3 cos theta minus 4 sine theta, which has given us what? Which has given us so 3 cos theta minus 4 sine theta is equals to 2.5. Back to the initial problem given to us. But now, when we said that 3 cos theta minus 4 sine theta should be equals to R, cos theta plus alpha. That was our suggestion initially. And when we end up getting what? Our R is now what? 5. We pick a positive value of R, cos theta plus alpha. This was our suggestion initially when we are given this problem. So we now return to the initial problem. The initial problem is 3 cos theta minus 4 sine theta equals to 2.5. and we said that problem show the left hand side of the problem should be represented by r cos theta plus alpha. That implies that and since our r is 5, we pick the positive value. No, we have 5 cos theta plus alpha. So in this case now, this now implies what? 5 cos theta plus alpha will be 2.5, because the whole of this left hand side has given us 5 cos theta plus alpha. Okay, now, so what next? What next? What next? The next thing now is what? From here we have cos theta plus alpha will be 2.5 all over 5, which is 0.5. So cos theta plus alpha is equals to 0.5. Now, using the general solution of cosine, general solution formula for cosine, that is x is equal to, plus or minus theta plus 360n, where n is an integer. I hope you can remember that. You are taught this. Where n is an integer. That is where n is an integer. Okay, you can replace this by, you can also write plus or minus theta, plus 2 pi n, because 2 pi is 1 in radians is 180 degrees times 2. That's okay. Then we can still use that. So in this case now, and we know virtually here that we have gotten what? 0.5. So we're now saying that what? Saying that since cos theta plus alpha is now 0.5, theta plus alpha now will be cos inverse of 0.5. We want to know the value of theta plus alpha. So, and that is it. So, and cos inverse of 0.5. Note or recall, cos inverse of 0.5, that is what? It's going to give us 0.5 is half. That is called 60 degree. That is 60 degree. If you convert 60 into radians, that is pi all over 3. That is pi over 3, yes. Because pi in radians is 180 by 3. So that invariably means that implies theta plus alpha is equal to pi all over 3. So in this case now, what next? Remember I said the value of the general solution formula for cosine is this. And so we can now invariably say that, how do we get our theta? Just what? Just by way of writing it this way. So suitably we have theta plus alpha will be plus or minus pi all over 3, then plus, plus, because theta is now plus or minus pi over 3, plus 2 pi n. Yes. Our theta plus pi is now what? Theta plus alpha is now pi over 3. So now the theta plus alpha, this theta plus alpha is like the entire theta itself that we obtain here, or that's, you can say it's like x. Okay, this theta plus alpha is x now. So writing it in form of the general solution of cosine, it will now be plus or minus what you obtain, which is this theta, or pi over 3 plus 2 pi plus 2 pi n plus 2 pi n. So the next thing now is the expansion. How do you expand this now? You have theta now is equal to, take this to the right, to the other side, you have minus alpha plus or minus pi all over 3 plus 2 pi n. Yes, plus 2 pi n. So now, if you want to find out the value of this, so this theta is now what? This theta is what? This theta is minus alpha plus pi all over 3 plus 2 pi n, or theta is equals to minus alpha minus pi all over 3 plus 2 pi n. I will explain it to you. You will see how we're going to arrive at the final answer. Now, don't forget, we have to substitute for the value of our alpha so that we'll be able to complete You can, in some cases, the examiner might expect the answers to stop here, but in some cases, they might want to extend the answer. So we now look for value of alpha in radians. Yes, value of alpha in radians is this tan. That is tan inverse over 1.333. The value of alpha in radians, I think, is 0.93. Yes, that is 0.93. 0.93. You check it. Tan inverse of 1.33 in radians is going to give you what? 0.93. And in radians also, in radians, pi all over 3 will be 3.142 all over 3. I think that is going to give us what? It's going to give us 1.03. 1.03. If you check, that is approximately 1.03. Yes, 1.03. Now a substitution. Now finally by substitution, theta will be, minus alpha, minus, what is our alpha now? 0.93 plus pi over 3 now is 1.03 plus, you can put this one as, you can retain this one as 2 pi n. So, okay, let's complete this. If we add this one together, pi will be equal to, if we add that together, minus 0.3 plus, that will give us what? 0.1 plus 2 pi n. Or the other version, the second one, theta equals to minus 0.93, then minus pi over 3 is 1.03 plus 2 pi n. So if you subtract that, if you evaluate that, you're going to have what? Theta would be, if you evaluate that, you have minus 1.96 plus 2 pi n. Hence, theta is 0.1 plus 2 pi n, or theta is equal to minus 1.96 plus 2 pi n. So with this, we have come to the end of this problem. So do well to click on the notification bell so that when I upload this video, you'll be duly notified. God bless you.